will probably jump directly to my talk and will tell you a little about the Apache Iceberg REST catalog, what's new, what's next. And maybe upfront, a question from my side, REST is a specification. So how many specifications do we have in Iceberg? It's a hard question. Maybe 1, 2, 3, 4? Who goes for 4? 4. So it's a table specification, view specification, path specification, and REST specification. And in my talk, I want to talk about the specification of REST catalog. Well, open source. It's actually why we all here, right? So Apache Iceberg is Apache Foundation open source project. And I usually try to understand from the participants, the current state of open source, and maybe if you can raise your hand if you use open source. So like everyone. So now a tricky one, who does contribute to open source? Oh, it hurts. So let's maybe just a motivational speech for the open source and for the innovation. Think about the contribution to open source is not just going and write code. It may be just test it out, write a review, change the documentation. So it's all different stuff what you can do with open source contribution. Therefore, think about that and go to a famous project like Apache Iceberg or maybe less famous project and try to contribute and just see what will happen with your career on that one. Because I can tell you that if you have experience in contribution to open source, it will absolutely help you. Well, my name is Viktor. I'm a co-founder of a company named Vakamo, and Vakamo is a team behind the Lakekeeper. So we created a Lakekeeper because we love open source. And Lakekeeper in itself, like in its core, is released under Apache 2.0 version. So everyone can just go and try it out. Don't need to tell us. We just see like the numbers of Docker downloads, and it goes today like to 90,000 per month. So thank you for trying out. Would be nice just to see some contribution. Cool. Before diving, maybe kind of a quick summary how we actually got to Iceberg. As you know, we had data warehouse. It was nice to capture some SAP data in that and run a report. Then we got internet and we got all that big data systems, and we need to store that in non-structural data like Hadoop and all the different systems. Then cloud happened. Sometimes it fails, sometimes it works. But with a cloud, we got actually a very cool stuff that a company like Snowflake or Redshift, they created a more or less fully automated experience with data warehouse. That number one. Number two is that they gave us a possibility to separate storage and compute. And that was a very cool innovation at that time. So you can actually store as much as you need, or as you want actually on storage, and then you can provision a compute as much as you need for your reporting. Well, guys on a big data said like we can do similar. So Databricks started and said we can do fully managed, we can separate storage and compute. Unfortunately, both had some pitfalls and drawbacks and disadvantages. So on the one hand, it was probably too expensive, and then you needed to make a decision what and how to store in data warehouse. On data lake, it was hard in terms of transactions, in terms of schema evolution. So you could store like infinite amount of data, but if you will get some kind of request about to delete from your data lake, GDPR conform, it was hard. So therefore the idea came around, so why not just to combine both systems to have a transactional guarantees and schema evolution, and at the same time be able to store like infinite amount of data. It's how we got to the Lakehouse. There are different open table formats, Delta, Hoodie, and Iceberg, and I would say, at least from my biased opinion, Iceberg is at the moment the most prominent and the most promising. It's why we're all here, right? So, well, that's a quick one. That's how the architecture looks like. So we have a producers, consumers, and they store and then they need read and write compute, and they need catalog. So to boil down the whole complexity, you need actually three components: storage, compute, and catalog. And now jumping to the catalog. You all know that picture, right? So it's an iceberg diagram where you have at the bottom Parquet, Afro or C, but usually Parquet files. And then you have a meta layer, and that meta layer is actually exactly how we can achieve that what you experience as a database table, more or less. Hello. Iceberg was invented 2017, and when we said like, okay, without catalog you cannot use Iceberg, so you need a catalog, and we had all the different catalogs: JDBC, Hive Metastore, we had Nessie catalog, and for the tools like Trino, Spark, Python, it was very challenging because they needed actually to implement the SDK of that catalog, and the adoption of Iceberg was a little bit slow. So it's why in 2022, we've got the REST specification to make a standard that everyone knows how to expose Iceberg data and everyone knows how to read the Iceberg data. And we can call it like after REST era. The interesting part is if you look at the square in that Iceberg diagram, the blue one, you will see that the REST spec got like additional competence to write the metadata JSON file. And that is quite interesting because through that, we can achieve a quite interesting capabilities with Iceberg. So after REST. And everyone started to talk about the catalog, and I had very interesting discussions with companies like, oh, we do have already catalog, Colibra, Atlas, Data Hub, and like, well, it's not the same catalog. We need actually to explain here what's going on. Luckily for us, Iceberg catalogs got additional components like fine-grained access control, and companies and users started to talk about the Metastore. And we got kind of analogy. We had the Hive Metastore. Hive was gone, Metastore stayed, and it's why we started to talk about the Metastore. When we talk today about this component, customers refers to a control plane because it looks like if that thing fails, you cannot read, you cannot write. Or more interesting situation, everyone can read and everyone can write. And yeah, the CISOs getting very nervous on that type of situation. Well, what's control plane? Well, the control plane sits in the middle and allows you actually from your tool, what you love, to read and write data. It can be open source Spark. It can be a cloud solution like Snowflake. It can be a single node DuckDB on your laptop. And then you can just go to every storage that supports well, object storage, like S3, Azure, Google. That's the mainly standards. We do have implementation with HDFS as well, but that's uncommon use case. And the cool part is that you can see that as on a construction, right? So if you want to build a house, you will probably say, well, I don't need a hammer because hammer can build the whole house. Sometimes I need screw, sometimes I need saw, and all the different instruments. And similar is here, you will end up as a customer that you probably can use a tool for 80% of your use cases. Let's say it's like Snowflake or Trino, and then you will have a specialized use cases where you can tell, oh, I need a DuckDB, or I need Daft to run my ML stuff. And well, maybe interesting approach for multi-cloud because when in V4 in the future, when the absolute path not going to be like the only one thing, but we will get a relative paths, then it would be easy just to go and more or less make standby type of a cluster and just copy the data from Iceberg and actually move your workloads to a different cloud as well. But the thing is about the control plane, and that's something what I want to dive in, is mainly about the governance. So it's less about that, oh, I can create the table, so I can go in and run the create table statement or alter table statement. It's about like how the companies, usually the big one who has multiple tools, they have Spark, they have Trino, they have Snowflake, they have maybe, well, I don't know, Databricks, but all that different tools. And the question is like, where am I going to put the access for a specific user, for specific table, for specific action. And what our perspective is that it is centralized in a catalog. And what we implemented at Lakekeeper is that Lakekeeper is the way how you can actually enable the access. So the authorization system itself is not built inside of Lakekeeper. So we took the Google Zanzibar paper implementation with OpenFGA. And that is outside of Lakekeeper, which means you can actually go and replace that with your own authorization system. So right now, what we implement is Open Policy Agent on that place and CEDA policy. So it's super easy because it's a Rust, it's a trait, and then you can just go and implement your own authorization system that will more or less get the information from, okay, I'm user and I want to read the specific table. So the main part is on our side, at least right now, so you can run Lakekeeper on Kubernetes. The important thing is that catalog shouldn't be an IDP. So you have your enterprise IDP, it's Entra ID, it's Okta, it's Keycloak, and the identity of user should live in that place, and catalog itself should not create any personal access tokens or something like this. Because you can imagine the situation when user left the company, then that personal access token can live even when the user is not inside of IDP. So you will have a challenge to disable the access. Important is you have two different types of compute. So a general compute where you have more or less a single user who is going just to access data, read, write. And that's a simple way to solve the problem because you will create a client ID and client secret in your IDP and give that to that general compute. The interesting part is on so-called trusted compute. So sometimes you have a multi-user systems like Trino, for instance, and then you have user A, B, C, D, and then you need to somehow to understand how that user is going to access the data and that you can prevent the access. And the cool part on Trino, for instance, at the moment is there's implementation, the so-called Open Policy Agent Bridge that allows exactly to achieve this. So the policy itself is stored in OpenFGA. If Trino runs the query, it goes to Lakekeeper, asks, okay, that's user A, and that information goes through the Open Policy Agent Bridge back to Trino, and Trino can enforce that policy. Well, sounds very complicated. It is very complicated. There are many moving parts, but that's something what we probably wanted, right? So if you wouldn't want that part, we will end up with Postgres and everything is going to be fine. The future is quite interesting because we trying to get rid of that moving parts, and there are different discussions in Apache Iceberg community. One of them, for instance, is the out manager. I think it was donated by Dremio, and it's quite interesting to see that with that out manager we can achieve something that we don't need the Open Policy Agent Bridge in the future. So if every query engine is going to deploy that, then we can really store that policy centrally, and that information is going to be available for every query engine. The next one, which is quite interesting as well, is UDF. It's still in discussion, and UDF is a more or less standard way how the things are going to be executed, but the UDF is going to be the Iceberg UDF. So, but every query engine can apply that, and why it's important and where can we use that? Well, the most question on that slide is how can I do column masking and row filtering? And the thing is, if you run your, for instance, general compute like Iceberg, for instance, you will eventually get the access to the whole Parquet file, and that's it, right? So you're not able to do the stuff. So with UDFs and with trusted compute, we can achieve following that the UDF is going to be applied on that query. And then you can very easily say like, okay, that person or that role has access only to data from UK, from Germany, from whatever, or that is a manager. So let's go and mask the salary data. And that's going to be possible through a concept of UDF, trusted compute, and REST catalog. And that will give you, again, like additional thing to control the stuff. Well, all in discussion, probably you kind of noticed that on Apache Iceberg it takes longer to make some progress sometimes. And therefore here as well, it will take a little longer. But the good thing for you is that you can actually be part of that. So you can go and discuss that. You can ask the questions. Even if you're not a PMC or contributor, you still have a possibility just to influence somehow, because if you're on a field, so more or less you're a customer, you can go and tell the community why you need this or that implementation. Federation, that's quite interesting. And maybe just to explain from a conceptual or from a business side, why we actually thinking about the federation, and why not like having a single catalog in a whole company. That what every data architect will probably tell you, right? So let's take open catalog, let's take Snowflake and our Lakekeeper, and then just let's try to get it in a single place. The reality shows that you will probably not be able to achieve this situation. So reality is that you have marketing with some ideas, and then you have HR. They have a different type of requirements. So marketing want to use Databricks or Amazon, and HR want to use Snowflake, and they're going to end up with two different catalogs. And then we have a bunch of people not inside of marketing and HR, but they want to get that data. They want to go and run their report, and HR and marketing will probably tell them, I'm sorry, it's our department, it's our data domain, you're not going to get inside of that. Go try to ask somehow, and maybe we will give you a CSV report out of that. So it's a huge business problem. And then we have a lot of AI LLMs who want to ask the question, and then same as here, probably even harder to give access to this type of applications, unless you don't care about the governance, but then you can say, okay, I have MCP and everyone can go and read. But that's probably a hard part, because there's a guy in the company who has a specific perspective on the things, how they should be done. And that guy will probably tell you, okay, so we need somehow to solve this thing, and the federation is the one logical approach in that case. And therefore, the federation on a catalog level is going to be very soon in a standard. I know like in Polaris, there is an implementation, but that was more or less proactively done by Polaris, not waiting for Apache Iceberg community. On Apache Iceberg community, my co-founder Christian Thiel, he was mainly driving that topic, and it's now through and can be implemented soon in Apache Iceberg spec. So that is quite interesting on different perspectives. So not just from a technical one, that you can take the catalog that suits your requirements from a technical side. So you have a specific requirement. Someone want to use, for instance, S3 tables because it's auto-compacted and they don't want to just take care of that. And someone want to use Polaris and run it by themselves. And then you still have a possibility to make a control and govern the access to all of the different data sets. Yeah, probably the last slide. Yeah, so the computational governance, and that's quite interesting, because as I mentioned at the beginning, on the REST catalog journey, the evolution of REST catalog, that catalog is now in charge to write the metadata JSON file. And here's like the thing, okay, so what can we do with that? Because before that, it was not possible. So the whole system, like Postgres, was in charge of managing the metadata and managing the state. So now we have a component that is in charge of writing the metadata JSON file. So every time if you run a commit, if you want to do any change on the table, at the end, catalog will go and write that file and make the final commit. So it's not Spark, it's not PyIceberg, it's a catalog. And here's quite interesting what we can achieve with that. So first of all, we implemented in Lakekeeper as a change streams. So what we can do, we can push every change on your metadata to a Kafka topic or to NUTS queue. And then you can create all the different system that can be used for risk, for fraud, for some different type of quality assurance activities. But what we're thinking about is probably, if someone is familiar with data mesh, and there's a one thing from a data mesh is a computational governance, which is solving following problem. We have a person from, in that case, from marketing, and that's a data engineer. That data engineer creates a table. Let's call it a customer table. And then we have a guy from sales who needs to fulfill the quota for this for this quarter. So there is a thing that they need to sell something. So we need to go out to the market, find the customer, make a business decision. What data engineer needs to do sometimes, they need to change tables, right? So they need to run alter table, or they need to drop tables. And if you go to a business where you have a lot of different users and you have a lot of different tables and objects, you will probably find sometimes the situation that someone dropped the table. I don't know, like on which side you've had that experience. You've been like on drop the table, or the guy 30 minutes later asking where's the table. So the problem is here that you have a huge amount of breaking pipelines upstream of your data source, where you will probably see numbers that companies losing millions because the data is not at the time when they need to make a business decision. But right now we in a different paradigm. We in a paradigm of Lakehouse and with Apache Iceberg. What we can do, we can actually react on exactly this thing. And next to a fine-grained access control, where we'll check the data engineer, and we will see that data engineer is owner of that table, we can check actually on a data contract where we'll define SLOs. And some of them are schema is not changeable, table is undroppable, data should be refreshed every day, etc., etc. You can think about the quality assurance part as well. So which means if that situation, the data engineer is going to run the drop table, Lakekeeper is going to tell him, unfortunately, I cannot do that because we have a relationship that is going to be enforced. So the consumer is protected in that case from a data engineer. I know from a data engineer perspective, the change needs to be done. But you have to understand that your colleague on the business side is probably going to be upset, and probably if you look at the very huge usage of that tables, that is super hard to understand where the pipeline actually broke. So where is that place that need to be fixed? But through that concept, you can actually fix the whole lakehouse and make it unbreakable in your situation. So we'll just finalize the talk about the catalogs. So maybe just as a takeaway, we don't talk about catalog anymore. We talk about the control plane because there are different things that can be controlled by Lakehouse REST catalog. So you can control access, you can control governance, you can control ownership. Ownership is kind of interesting as well. So imagine you have a table, and that table belongs to Jon Snow, and then you want to make a change. You go and ask him, where is John? Well, John left company for 2 years, and no one knew that, right? So, but the thing is about any catalog, because you have a link to IDP, and you know that if that identity is gone, you can react. So all the different things from a control thing can be done here through catalog. Well, federation, raw filtering, color masking, coming soon. Therefore, that I would say one of the most questions that can be answered pretty soon. So you can use your trusted compute, mask your salaries, your credit cards, and use the whole Iceberg Lakehouse system. Yeah, so the metadata innovation, so the whole thing, and maybe for you as well. So if you think about the last 20 years where data was on the main stage and everyone was building a system around the data. Customer was on the website, or let's go and do that action, send a voucher to that customer or call the customer. But at the same time, everyone was complaining about data quality, data ownership, data governance, and that's something what you can actually solve through the metadata. So now you have an ability to make metadata actionable. And that's where catalogs shine, and you can do all the different stuff what was not possible before. Yeah, and finally, what we see as well is that you can actually use the catalogs and that contracting mechanism through that metadata stuff to share your data. I mean, You know that probably from Databricks with Delta Share, and I think that's going to be the part of Iceberg someday. And then we can actually go and share data through catalog even outside of a company. So you have your partner network, and if you're in a part of supply chain, then you can inverse the data flow back to your partner who got your physical good, and actually do interesting stuff as well. So I will pause here. That's it from my side, guys, about the catalogs. If you have any questions, you can ask now or later. Any questions? No? Oh, there is a question.
There's one in the chat.
Yeah, so let's ask.
Maybe I'll just read it out because we've got some microphones here. So we had one, can we use ODPS/ODCS in the contract engine?
Absolutely, you should use ODS. Yeah, absolutely. That's the way. So it's all about the identities, right? So the question is relatively interesting. If you're inside of a company, then you can use that. If you're outside, it's going to be a different approach.
And then follow up, would you share the SDK for the data contract engine? Like, I guess, is that open source?
Well, we thinking about to open source it one day. And there's a question in the back, maybe to pass.
Thank you, Viktor, for a nice presentation. I really like it. And my question is around UDFs. So UDFs, if they kind of like be part of the catalog, it would be a bit complicated because some engines, for example, Starox, they actually consult catalog for metadata, and then the actual download with Parquet files and predicate pushdowns and other stuff is actually done by executors from the engine. So this way, UDFs would be skipped. So how to actually unify this and make it possible?
Use a different engine?
No, only Starox.
No, well, to answer that seriously, we are in a good discussion with Starox guys, and probably we need just to dive in on UDFs. And I think looking how Starox is actually evolves around Iceberg, I'm pretty sure they're gonna support UDFs as well. Maybe they even going to support Scan API from a catalog, so they not going to do the planning by themselves, but they will reach out to catalog and ask catalog to give the plan that can be executed on the executors. But yeah, so right now the thing is UDFs is in discussion. It needs to be approved, implemented or described, and then every engine will probably look at that, and I'm pretty sure Starox is going to implement UDFs as well.
Okay, thank you.
I hope Sida or someone from Starox got. Okay, perfect. Then.
Cool. Thanks, Viktor.
Thank you, guys.